So finally, we are going to start trig. So we're going to look at our three basic trigonometric ratios. So you want to have your scientific calculator handy. And I know most phones have the scientific calculator built into them as well. And in a pinch, feel free to use that. But again, for your tests and quizzes, you need to have an actual scientific calculator. Okay? Um, just a note, as you're working through this, if you're not able to figure out how to use the buttons on your calculator, make sure you ask me in class tomorrow so I can go over how to work with that with you guys. Okay, so let's start with what are our trigonometric ratios. So we have what's called sine, cosine, and tangent. And this relates sides to angles. So what we always want to have is some angle of reference that we're using to find our trigonometric ratios. So if you notice here, I'm saying let's just use angle A, and angle A. So we're going to be looking at this angle as our side of reference point. Okay? Before we talk about what sine, cosine, and tangent are, I want you to think about how we can label the sides of this right triangle. Remember, it must be a right triangle for these ratios to work. So we can always start with what is across from the right angle. Well, what's that side called? Hopefully you remember that's called the hypotenuse, which I'm going to abbreviate with HYP. Now, what we want to look at now is what are the other two sides, BC and AB, from angle A. And these two sides change depending on which angle you look at. So if we're looking across from angle A, I've always called that the opposite of angle A. So that's going to be our opposite leg. So I'm going to use OPP to represent opposite. Okay? And then this leg right here, that's BA, see how it actually goes and hits that angle A? Well, we call that the adjacent leg. I'm going to use ADJ to represent adjacent. Okay? And again, opposite and adjacent will change depending on your reference angle. So if we're looking at C, then BC becomes adjacent and AB becomes opposite. So don't always think it looks like this picture. Okay? But again, we're picking angle A as our reference point, so I'm using AB as adjacent and BC as opposite. So what is sine? So we use the notation SIN for sine, so please say sine, not sin. And you'll see the angle right next to it. So sine of angle A, that's how we read that, is going to be the opposite leg over the hypotenuse. So that would be BC over AC in this example. Okay, what is cosine? So cosine we abbreviate with COS. So that's cosine, not cos, so please say cosine. And again, the angle will be right up next to the trig function, the trig ratio. So cosine of A is equal to the adjacent leg over the hypotenuse. So in this problem, it would be AB over AC. Finally, the tangent is that final combination. And to use tangent, we abbreviate with TAN, but again, not tan, but please say tangent. And the angle right up next to it, tangent of A, is equal to opposite over adjacent. So that would be BC over AB. Okay? Oops, that's AB. So just to be very clear, sine, cosine, and tangent themselves, they are actual operations. So you can't divide by sine, you can't multiply by sine. Sine has to go with an angle measure because it operates on a number. So we can't divide by a sine, divide by cosine, or whatever. It has its own inverse operation, which we'll talk about in the next lesson. So please be aware of that. Okay? An acronym you're going to hear to represent trig ratios that might help you remember them is called Sohcahtoa. And this just means sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So I like this because it just saves a little bit of space on your note cards if you just write Sohcahtoa, and hopefully remember O is opposite, H is hypotenuse, and A is adjacent. And then you can remember what those ratios look like. Okay, let's practice this with example 1. So we want to find each ratio and round to the nearest hundredth. So remember, make sure you look at the directions to tell you how you're rounding. Hundredth is 2 after the decimal. All right, so sine, well, what is sine? Well, sine should be opposite over hypotenuse, but don't just pick any random side to be opposite. We want to look at angle J. So J is our reference point. So then which side would be the opposite and which side would be the adjacent? Because clearly hypotenuse won't change. That's always across from the right angle. All right, so hopefully you're remembering KL is the opposite and JK is the adjacent. And we're going to use that to create our ratios. So sine of J should be opposite over hypotenuse, which is KL over KJ. So that's going to get me 60 over 61. Now go ahead and use your calculator and divide that. 60 divided by 61 should be a really ugly decimal, right? 0.9836, etc., etc., etc. And let's just round that. So using your approximation sign there, it's going to be approximately 0.98, right? The 3 is less than 5, so I don't round up. Go ahead and now try cosine and tangent, remembering what those ratios would be. So go ahead and check your work. Did you get these ratios? 11 over 61 for cosine, 60 over 11 for tangent. Rounding to the nearest hundredth, we get 0.18 and 5.45. If it said leave your answer as the exact number, leave it as the fraction. So just make sure you're reading the directions for that. Okay? So that's sine, cosine, and tangent. Remember, feel free to pause if you need to jot these down in case you didn't do it before you keep going to listen to the explanation. But let's move on to example 2 if you're ready. So we're going to round to the nearest hundredth again. Remember, if it said leave your answer in the exact form, I'll show you what that means in a moment. But we're going to find BC. So now you really have to ask yourself, well, what should I use? Sine, cosine, or tangent? I'm just going to rewrite Sohcahtoa up here so I can remember what those ratios are once I've decided. Okay? And you know what I realized? I forgot to put something on here. So let me pause for a moment and give you the English. And there you go. And I should have fixed that on your paper. So you should already have that 15 degrees there. Okay? So we want to ask yourself, sine, cosine, or tangent. And remember, you always need a reference angle to decide what you're using. And in general, you will never want to use a 90-degree angle because when you use a 90, the ratio, when you put it in your calculator, is going to be just all off. So don't use that, that 90 degrees. So we want to look at one of the other two angles and notice how I'm given this 15. So that means I probably want to use B as my reference. All right, then I want to see what am I looking for? I'm looking for BC, so I'm going to call this X. And now using B as my reference angle, I want to think, well, what do I know? Well, I know the opposite is 10.2, and I know I'm looking for the adjacent. Now, which of these three ratios uses opposite and adjacent? Well, hopefully you realize that's tangent. So I'm going to set this up as tangent B is equal to opposite, which is AC, over BC. And then plug in my value. So tangent 15 is equal to 10.2 over X. And then you can go ahead and solve. And what you can do if this is looking like, wait, how do I deal with this? Because X is in the bottom. I suggest you make it into a proportion. Remember, tangent 15, if you put that into your calculator, it's going to be some really ugly decimal, but it's still a number. So I can make that as something over 1, right? And then I can go ahead and cross multiply and solve. So I'm going to get X times tangent 15 is equal to 10.2 times 1, which is just 10.2. Then I'm going to divide by tangent 15. Remember, tangent and 15 are stuck together, right? We can't divide by 15 separately and tangent separately, but we have to divide by whatever tangent 15 is, because if you look at it in your calculator, it's just one giant number. Okay? So X is equal to 10.2 over tangent 15. And this is the exact answer. So when you get to your quiz that says no calculators, you're going to stop there, and that's okay. But since we want to round, let's go ahead and put this into your calculator. So we're going to get X is approximately, and here's what you want to look for. You're going to do 10.2 divided by tangent 15, and depending on your calculator, you either put the tangent button first or second, and you kind of want to play with it until you see about 38.07 feet. Okay? So play around with your calculator for a little bit, see if you're getting 38.07 or 38.06691824 is what I see in my calculator. If you're not getting that, make sure you make a note of this to ask me tomorrow, and I can show you how to do sine, cosine, and tangent in your own calculator, because every calculator is just a little different. Okay? Finally, example 3. So here's where special right triangles comes in because we're talking all about right triangles right now. So I want to use special right triangles to figure out the trig ratio, and I don't want to do this as a rounded answer, but I want to write my answer as a fraction. And here's why I don't want you to always use calculators, because I want to see you guys can do this type of problem, the 45, 45, 90, 30, 60, 90, without a calculator. But before we figure that out, let's remember, what do I know about 45, 45, 90 triangles? Well, remember with 45, 45, 90, we know it's isosceles, and the hypotenuse is x square root 2. 30, 60, 90, this is scaling, but we know one angle is 60, one angle is 30, and everything goes back to that short leg, right? Which I can call x, actually. Let's call this x. The long leg is x square root 3, and the hypotenuse is 2x. And that gives me the angle measure I need and the side lengths I need to figure out sine, cosine, and tangent. So I don't even actually need any values here. All I need to do is figure out what's the relationship between the three sides to figure out sine, cosine, and tangent. So if you take a look at the example down here, what kind of special right triangle is this? Well, hopefully you're seeing this is a 30, 60, 90 triangle. So now go through and label what's x, 2x, and x square root 3. Remember, across from 30 is x, across from the 60 is x square root 3, and the hypotenuse is 2x. And I want to do sine of 60, and I'm just going to jot down Sohcahtoa so I remember how to do my ratios. I know sine is going to be opposite over hypotenuse because it's OH, it's so. And then I want to think, okay, if I'm looking at 60, so 60 is my reference angle, then 2x, of course, no matter what, will be the hypotenuse. X square root 3 is going to be the opposite, and x is my adjacent. So using that information, I can figure out that ratio. So I'm going to plug in the opposite, which is x square root 3, the hypotenuse, which is 2x, and then I can just simply reduce, right, cancel out the 2x's, and that's going to give me square root 3 over 2. And that is what sine of 60 is. Okay? Take a look at tangent 30. I'm going to let you guys try this one on your own, but first remember, now that we're looking at 30, my reference angle has changed, right? So now with the 30, this x square root 3 is now the adjacent, right? This x is now the opposite, but the hypotenuse is still hypotenuse because that never changes. So now use that information to figure out tangent, thinking about what TOA stands for, and let's get that fraction. So did you guys get 1/2? Because 1/2 is the answer. So just remember, if you can cancel out an x and an x like this, and there's nothing left on top, don't write 2. There's that invisible one left, so make sure you're writing 1/2. Okay? We'll practice this in class, and again, if you have calculator questions, please, please, please ask me. Please bring calculators that you're using on your tests and quizzes with you, because you don't want to practice this on your phone and suddenly have to figure out your calculator on a test or quiz, because then I'm not going to sit there and teach it to you then. Okay? I'll see you guys in class.